This is a quick review on how to solve the problems on your Chapter 4 test, quadratic functions and factoring. Not all of the problem solutions will be given, but helpful hints will help you determine how to solve the problem. Problem number 1. This function, you want to find the vertex and axis of symmetry. On page 238, it tells you that your vertex and axis of symmetry can be solved if it's in the right form by negative b, this is the b value, divided by 2 times a. Here's your a value. When you solve for your x, you not only have your axis of symmetry, but you have the first point in the vertex. The vertex is going to be x, y. So once you find the x value, by solving this, you plug it in to the equation, and then you solve for y. And that will give you your y value. So now you'll have your x and your y, and you'll have your axis of symmetry because that will be equal. Let's look at number 2. Number 2 asks you if it's opening up or down. It actually says if it opens down, which of the following must be true? Well, we know on page 237 that if you have a negative coefficient, then that means that it opens down. If you have a positive coefficient, it opens up. So you simply can use that information for this problem. In question number 3, it says which does not have a maximum value. On page 238, it tells you that if you have a positive coefficient, it's going to open up. Well, if it opens up, it only has a minimum. If it's negative, it opens down, so it only has a maximum. It doesn't return back up again. So here you're simply looking for the coefficient of a that only has, that does not have a maximum value, but that would have a minimum value. Number 4, what is the vertex of this? Well, they conveniently put this in vertex form already for you. This is the vertex form of how to write an equation where the vertex is simply going to be h and k. Now be careful because there's a negative sign here. So there's supposed to be a negative sign. So h would be 2 in this case, and k would be negative 4. Number 5 on page 246, it says what are the x-intercepts? Again, they've put it in the form for you. Y is equal to a, x minus p, and x minus q, where positive p and positive q are the intercepts. Be careful because you have to subtract them. Well, this is conveniently subtracted, so we know that p is 7. But this one is added, so you're going to have to change the sign of q to match that. Let's look at number 6. It asks you to factor this expression. And when you factor this expression, you want to make it so that on page 252, it explains that you want to make it so that when you add these two together using your FOIL method, you're going to need to get the correct sign. When you multiply these two together, you're going to also need to get the correct sign. So you want to make sure that when you add negative 7 and negative 3, you get negative 4. That would not be the case. Negative 7 and a positive 3 would give you a negative 4. When you multiply negative 7 times positive 3, you're going to need to get a negative 21, and that's what you get. So you'll want to use your FOIL method. Number 8, there's helpful hints on page 852. Let me make sure I didn't skip a problem. I think we skipped number 7. Let me go back to 7. Okay, number 7 asks you to complete the square. The answers to that, or helpful hints, are on page 284. To complete the square, you simply take your b term, divide it by 2, and then square it to make a perfect square. So that's the solution that you're looking for. b over 2 squared, and here's your b value. Going back to number 8, what are the roots? The roots are the same as the solutions to the equation. So on page 252, it tells you want to factor it out, and then if they're added, then you're going to have negative values. You set them equal to 0. So in this case, it would not be negative 4 and negative 5. You would set x minus 4 is equal to 0, so x is 4. X minus 5 is equal to 0, so x is 5. So be careful when you're setting the solutions equal to 0 that you take into account the correct sign. Okay, number 9, there's helpful hints on page 260. And it tells you how to factor an expression. When you have a coefficient for x squared, you want to make sure that you try to reduce it as much as possible. So like in this case, I divided everything by 5 to try to simplify it, and then I simply factored out the other. So you want to make sure that you factor out your constant first, and then whatever's left should result in the equation up here. Number 10, if you look at page 267 of your textbook, it asks you to rationalize the denominator. What is our goal here? Why do we rationalize? What does that mean? Rationalize means you want to get rid of the radical or an I in the denominator. And the way to do that is by using this handy-dandy formula where you can take, if it's added a plus b terms, you can multiply by its conjugate, a minus b. If it was a minus b, you could multiply it by a plus b. Either way is fine. You're going to result in a squared minus b squared. That's nice because here's your a. You're going to get 49. And then a square root squared gets rid of that square root in the denominator. Then you can simply keep reducing as much as you can in order to get rid of. But it's okay to have a radical in the numerator. It's just not okay to have a radical in the denominator. Let's look at number 11. It says, what are the solutions to the equation w squared is equal to negative 9w? Well, this you can just simply put all your variables on one side. You always want to have all your variables on one side. In this case, it's m. And you can factor out an m and just simply get m plus 7. We'll set m is equal to 0. It's the same as if you said m plus 0 and m plus 7. It's the same thing because there's nothing added to m. So you could set m is equal to 0 and m plus 7 equal to 0, and those would be your two solutions. Number 12, you can look at page 293, and I would use the quadratic formula here. First, I would simplify it so that it would look like this. So I would go ahead and multiply my square out and then distribute my 2, rearrange my 23 on this side. So when you do all that, you can use the quadratic formula. There's more than one way to solve the problem, but that would be my suggestion. Okay, looking at number 13. Number 13, you can look at page 275 where it talks about complex numbers. And so obviously your answer is going to be one of these two. So in this case, I gave you an example. You would square root both sides. Remember, the square root of negative 1 is I. And then inside the radical, you want to see if you can find a square. Because if you can find a square in a square root, then you can simply pull that out. So that makes it easy. Okay, number 14, there's some help on page 276, and they tell you the standard form is going to be a real and an imaginary portion. Remember that I squared is equal to negative 1, and so what you want to do is rationalize the denominator like we were talking about before. This is a plus b, so I'm going to use a minus b to get rid of the I in the denominator. That's what rationalizing is. You want to try to get rid of radicals and i's. So here's a plus b, a minus b. That conveniently turns into a squared minus b squared, which when you square I squared, you get a negative 1. And then whenever you do this, you want to continue to simplify to get the simplest answer possible. Okay, let's look at number 15. Number 15 asks you what is the absolute value of 3 minus 4i. Well, the formula for absolute value when you have a real and then a complex component is you square the real, you square the coefficient of I, and then you take the square root of both. For example, if I had this problem, here's my a squared, here's my b squared. I add them together, and then I simplify under the radical. You would do the same thing here. Number 16, what is the vertex? You look at page 245, and it tells you that the vertex is x and y. So again, x, you have that same formula that we did before. So you just take your negative b and then divide it by 2 times a. That gives you your x value. And then y is simply whatever x is. When you plug that value in for x, you just solve for y. And so I gave you an example here, but we've done that before. Okay, let's look at number 17. What's the value of the discriminant? The discriminant is b squared minus 4ac. Bottom line, you have to know that. So it has to be in this form. So we have an a, b, and a c, and we know that it's 41. So for example, if you put your b squared, so here's your b squared, negative 3 squared minus 4 times a times c is equal to 41 because they gave you the value. So you just simply solve for c. Okay, number 19, you should know that it says how many real solutions are in this. Well, you look at your discriminant, and remember the discriminant is what's going to end up being when you use the quadratic formula, negatively plus or minus b squared minus 4ac all over 2a, okay? The discriminant is what is underneath the quadratic, the radical. If this is a positive number, well, then you're just going to get plus or minus a real number. If this is 0, well, then you don't even have a radical, and so you end up with a constant, so you have one real solution. If this is a negative number, well, you're going to have a complex or imaginary solutions because of the fact that you have a negative under the radical. So these words or these rules about discriminants just help you determine what kind of solutions you're going to have. In this case, when you solved for b squared minus 4ac, you have 5 squared minus 4 times 7 times 1. You end up getting 25 minus 28, which is a negative number. Well, if you're going to have a negative under the radical, you're going to have 2 imaginary solutions. So how many real are you going to have? 0. Okay, to graph these functions, you want to label the vertex and the axis of symmetry. So the first thing you do when you graph the function is, this one happens to be in the right format. So you can find your vertex by looking here and here. All I did was rewrite this in this form. Okay, so I know that my origin is my vertex. My axis of symmetry is whatever the x value is for that origin. You could have also used the x is equal to negative b over 2a to find out that value. It doesn't really matter. And you know it's pointing down because your a is a negative value. Over here, it already conveniently gives it to you in vertex form. So this is a negative 1 because it's x minus h, x minus a negative 1. So that's going to be your axis of symmetry. And then k is negative 2. So your vertex is negative 1, negative 2, and your axis of symmetry is that. Stay tuned for the next video for the free response section of this test.